last couple questions of this section. So for this one, it says it's common for stores to advise a certain percentage off, then say the discount is reflected in the marked price. And then you just have to trust that their math is good. So here we go. Suppose the refrigerator is listed as 30% off with a sale price of $7.49. What would that make the original selling price? Ooh, tough question here. So let's break it down. What do we know? So we know that we have a 30% off as an advertised amount. So this is the discount, and that's off the original. And we know that the sale price is $7.49. So if I could make a little diagram here that might help. So somewhere we have 100% of the price. That's the original price. This is unknown. We don't know this value currently. We're going to calculate that. Often if you look at Amazon or other places, they strike a line through it and then show the discounted price. Well, then we would take 30% of that amount. So if you think about what happens, we do 0.3 times this unknown amount, and that would give us the discount, the amount of the discount, some sort of dollar amount. And we would, if we knew that discount amount, we'd subtract it from this original price and we'd get the sale price. Well, the sale price we happen to know. In other words, the price we pay at the counter, that's $7.49. Now, if we think carefully about what this means, this price represents 70% of the original because we took 100%, took away from it 30%, and we got 70%. So back up here when I said 0.3 times the original amount equals the discount amount, we can't use this calculation because we also don't know the amount of the discount. This is also unknown. We can't solve an equation that has two unknowns unless we had two equations. So we could use this because we know that 70% of the original is $7.49. That means if we take 7% of this original price, when we multiplied that together, we would get $700.49. If you go back to that discount one, you'll see this sort of setup being done, this kind of algebraic way to solve this problem. You will often see in algebra classes that instead of using words, they'll use letters to represent unknown values. X is often a commonly used one. You're going to see that in Unit 2. So we just got to solve this. Well, if we were multiplying to get the amount, the inverse of that is to divide. So a very algebraic kind of solution here would be to divide both sides by 0.7, and that is going to get us the original price of this refrigerator. So $7.49 divided by, that's a question mark, divided by 0.7, it's $1,070. Couple things to note here. If you did this calculation and you got a number that was smaller than $7.49, you definitely know you did something wrong because the original price has to be more than the sale price because we took a discount. We took 30% away. All right, next question. So we got this large latte at Shakey's Caffeine Shack, usually sells for the low price of $3.50, but today Shakey's has gone goofy and is offering it for just $3. Great. The coffee shop across the street is offering 20% off. Which store is offering the better deal? Now we have to make an assumption here that the price of the coffee shop across the street is the same for the same cup. So we have to assume the $3.50 is the same for Shakey's and across the street. Okay, so again, we have two ways to solve this. One way, we could look at the amount of discount. So here's the original price, $3.50. Here's the current sale price at Shakey's, $3. So the amount of savings, the amount of discount is 50 cents. Let's call this Shakey's. We'll call the other one the street. Well, the street is offering 20% off. So we'll take the original price, $3.50, and we'll calculate what's 20% of that. So we'll multiply that by 0.2, and that should get us our answer. Well, that'll get us the amount our discount amount. Oops. So let's do that. $3.50 times 0.2, and we get 70 cents off. Ooh, hey, in this case, the 20% off is the better option because 70 cents is larger than 50 cents. So you get a bigger discount. We could calculate the percent 50 cents is of the original, so we could do what's 0.5 divided by 3.5, and then we could compare the percentages directly. Might as well do that just for fun. I have a broken mouse, so it double clicks every time I click it. That's what's going on. No. It's terrible for gaming. Okay, so this shows us that the 50 cents off is approximately 0.143. Let's round to the third decimal place. And converting that to a percent means we were saving 14.3%. Definitely better across the street. All right, so this kind of leads us naturally to a little formula. If we want to calculate a percent decrease, it's what it is, it's the amount that some quantity is decreased as a percentage of the original amount. That's precisely what I'm doing right here. This is the amount of discount. This is the original price. So what percent discount is it? We could also do a percent increase. If a price went up, we would find the amount of increase and then divide by the original amount. So we get these two formulas for percent increase and decrease, and they are the exact same formula, just different words. If you have a percent decrease, you should get a negative number if you set it up correctly. If you have a percent increase, you should get a positive number if you set it up correctly. So I like to summarize both of these formulas into this formula, new minus old divided by old. Okay, what's important is that what we subtract is what we divide by. Notice we're going to call this formula the percent change or the relative change. And we know that if we get a negative number, that's a percent decrease. And if we get a positive number, that's a percent increase. One other note here is that when we do this division, we're going to get a decimal. If we multiply that decimal by 100, then we will get the percent change. Okay, only after we multiply by 100 can we slap a percent sign on there. So be mindful of that. All right, so let's try one quick problem here. Here in 2019, the state minimum wage in Missouri was raised from $7.85 to $8.60. In Massachusetts, it went from 11 to 12. Which state had the higher percent increase? Great question. So we can identify these as new minus old divided by old. So the old number here is 785. The new number is 860. So for Missouri, we're going to do 860 minus 785. Key point here, divided by 785. We're wanting to know how much did it go up relative to the original amount. We could flip this and we would get an interesting number. Let's just say that. Okay, and then on the next one, the new number is 12 minus 11 divided by 11. Okay, so we'll get these percents, both of them, and then I'll write them down and we'll talk about them. So we've got 8.6 minus 7.85. Be careful, we need parentheses here because we need that subtraction to happen first. So it was a 75% increase, and how much of that increase is it relative to the original amount? Note that's about 10%. I'm going to put 0.0955. And for the other one, it's 12 minus 11. I don't know why I'm typing that in. That's pretty clearly 1, but whatever. Divided by 11, and that's approximately 0.0909. Okay, so which one had the higher percent increase? Well, let's multiply both of these by 100. That means move it 2 places to the right. You'll see why I chose 4 decimal places. it's a little easier to compare. However, if we round these to the nearest percent, this one would have been 10%, this one would have been 9%. So it's still, this one is still clearly higher. Now I got to be careful here with this. So Missouri gave a higher raise. Overall, people that live in Missouri are making less money than people that live in Massachusetts, as in terms of minimum wage jobs. However, what you would need to look at to decide, oh man, I'm going to move to Massachusetts because they pay more, if your goal is to work minimum wage jobs, you would want to look at the cost of living, because it might be relative to the cost of rent and food and all the rest, this $12 buys you less things than this $8.60. So that's just a side note about money. All right. Next question here. Our author shows us how to do some stuff in Excel. That's nice. We're going to do some Excel in this class. And what we're asking here to do is calculate percent change up here. So we've got the original amount, the new amount, the amount change, the percent change, and the percent change form. So this says write the formulas that appear in cell C3. So here's C, and here is the row 3. So we're looking at how did they get that 0.7, and D2, how did they get that percent change formula? Well, if you look at what's happening in this amount of change, what they did is they took the 725 and subtracted from it the 655. That's that new minus old. So the way Excel does this is to put a formula into the Excel thing, to do a calculation, you hit your equal sign, and then you would select cell B3. You just click it and it would show up in a different color. If you're doing this in Excel, go for it. And then we would put in the minus sign. So there's the operation we're telling Excel to the calculation, and then we'd pick A3, and that would be the formula. Well, then in cell D2, we've now got that decimal. So if you remember what happens, we do new minus old divided by old. So in this case, we would have done this calculation, which got us that 0.7. That's the value in C2. And then we would have divided that by 7 wrong by 6.55. So for Excel, the formula we would use is we would hit the equal sign. We would select the C3 cell. That's where we have our 0.7 listed. Then we do the division symbol, which is like the slash. And we would click cell A3, and we would get our answer. Boy, I wrote all that and you couldn't see it. Okay, that's it.